Understanding a matrix equation may be easy if we see how closely it is related to a linear equation. As a matter of fact, a matrix equation is used to solve a system of linear equations. Therefore, the analogy between a matrix equation and a linear equation are very, very close. Now we have the matrix equation right here on the left, which is a system of equations that we are using a matrix to solve. On the right hand side, we have a single linear equation. Let the unknown be x in both cases, and we are constructing an analogy between the matrix equation and a single linear equation. The unknown will be x in both cases. The known value that multiplies x is a. The known value that multiplies x is a. We are just using symbols to represent them at the moment, but a should really be a known value. Also, b should be a known value. The known result on the right hand side is b, and we are representing the known value on the right hand side by b. Therefore, we are just using symbols in our explanation, or to make our explanation easier. But we need to understand that only x is an unknown. All the other symbols represent known values. In solving the equation, we need to eliminate a, that is multiplying x, on the left hand side of both equations. And we need to do that by dividing by a. We need to eliminate that a. We divide by a on that left hand side to eliminate the a that we have multiplying the unknown on the left hand side. We also need the equations, both equations, to be balanced, and that will be achieved by dividing by a on the right hand side of each equation also. Consider that we have matrices on one side, and we cannot divide by matrices directly. This side represents matrices. All of the components on the left hand side of the table are matrices. We cannot divide by matrices directly. Dividing by a matrix is achieved by multiplying by its inverse. While we don't have to bother about the column on the linear equation, we have to be very conscientious about the side on which we have the matrices, because we cannot divide by matrices directly. We multiply by the inverse, and that is how matrix division is achieved. As a matter of fact, we know that dividing by a number also is the same as multiplying by its reciprocal. That is called the multiplicative inverse. It is the reciprocal form that we are using in this explanation. Even for a number, the division by a number is also achieved by multiplying by the multiplicative inverse. And the multiplicative inverse is the reciprocal. Therefore, dividing by any number is achieved by multiplying by its reciprocal. Multiplying by a multiplicative inverse is not limited to matrix division. We also do the same when we are dividing numbers regularly. For the matrices, we know that for this step that we are at, for the matrices, we know that A inverse times A will give us the multiplicative identity, which is called I. And for the linear side, we know that A divided by A is equal to 1. And 1 is also the multiplicative identity for numbers. The analogy is very, very close. A inverse times A will give the identity, the multiplicative identity for matrices, and when we divide A by A, we have 1, and 1 is the multiplicative identity for regular numbers. A inverse times A is replaced with the identity, and A divided by A is 1. Also, the identity multiplied by any matrix X results in that same matrix. If we multiply the identity times X, the result is X. And if we multiply 1 by X, the result is X. 1 times X is equal to X. 1 is our everyday multiplicative identity. Identity times X results in X, and 1, which is our regular everyday multiplicative identity, times X is also X. The only thing that we need to do in order to find X is to find this matrix product, and we are finished. Therefore, in solving a matrix equation, we multiply both sides of the equation by the inverse of the matrix that is multiplying the unknown. This is the matrix that is multiplying the unknown. In order to solve this equation, we need to multiply both sides of the equation by the inverse of this matrix, which is multiplying the matrix of unknowns. By so doing, the left-hand side will simplify just to the matrix of unknown, and our job is just to multiply the right side of the equation by the inverse of the matrix. Now this side will just simplify to X. That is not a headache. Our real task is to multiply the right hand side by the inverse of the matrix that is used to multiply the matrix of unknowns. It is not necessary to show the details of multiplication on the side of the unknown, because by multiplying by the inverse matrix, that side will simplify to the unknown. When we multiply this side, we don't have to do the entire multiplication of matrices and show how we arrive at the answers and all of that. We don't need to do that, because we know that when we multiply the left hand side by the inverse of the matrix, it will simplify just to give X. That side will simplify to the unknown. Our task is to find the matrix product on the other side. So the real task is to find this matrix product, which is the inverse of the matrix that is used to multiply the matrix of unknown. We need to use that to multiply whatever we had initially on the right hand side. We will show that if the linear equation were treated like a matrix equation, the result will be the same. And we will recall a bit of indices. We are going to go to our laws of indices. By recalling a bit of indices, how we manipulate the laws of indices. 3x is equal to 15. 3x is equal to 15. We are, on this occasion, multiplying both sides, right here, multiplying both sides of the equation by the multiplicative inverse of 3, which turns out to be 3 to the negative 1, which is the multiplicative inverse of 3. And it turns out to be equal to the reciprocal of 3, because 3 to the negative 1 is 1 over 3 to the power of 1, and 3 to the power of 1 is 3. Therefore, 3 to the power of negative 1 is just 1/3. We will therefore replace these with 1/3. And on this side, which we are working with just pure numbers, no matrix consideration, although we are really working with pure numbers, on this side also, we are treating it as if we are multiplying by matrices and see if the result will be the same. We go straight ahead because we are just dividing real numbers or regular numbers. Say 3x divided by 3, the 3's will cancel and we will have x. And 15 divided by 3, that will give us 5. X is equal to 5. Here, what will happen? 1/3 of 3x is x, and 1/3 of 15 is 5. For the manipulation of numbers in a linear equation, there is no wool over the eye. We know that the multiplicative inverse of 3 is 1/3, which, when we multiply by, gives the same result as dividing by 3. We will have the same result as dividing by 3 because we are multiplying by the multiplicative inverse. And the result will be, in the same breath, x is equal to 5. In our regular arithmetic, we may divide or multiply by the reciprocal. For matrices, we must multiply by the multiplicative inverse, because we may not divide by a matrix directly. Additionally, in regular arithmetic, multiplication is commutative, while matrix multiplication is not commutative. We must be very careful about the order in which we multiply matrices in a matrix equation. Teachers and instructors, get unlimited access to teaching aids for your virtual classrooms at richardjamesmathematicsresources.com. Also, this is the best place for the hearing impaired to master mathematics as long as you are literate.